All right, suppose there's an economy where the representative market basket to calculate the aggregate price level consists of two goods, and it happens to be that the weights for the two goods are that there are 6 units of good X in the market basket and 2 units of good Y in the market basket. So that's the market basket, 6 units of good X and 2 units of good Y. Okay. And suppose we have this price data for 2 years, 2014 and 2015, and the price of good X in 2014 was $5, and the price of good Y in 2014 was $10, and then in 2015 the price of good X was $6, and the price of Y was $9. So we can use this information to calculate the rate of inflation in this economy, this very simple economy where there's only two goods, as such, right? So using this information, we can figure out that the value of the market basket in 2014, well, it's just the prices from 2014 times the quantities in the baskets, right? So the $5 times the 6, right? $5 times 6 plus the $10 times the 2 units of good Y that are in the basket. So that's going to be $30 plus $20, which is $50. So the value of this market basket using the prices from the year 2014 is $50 in the year 2014, right? Doing the same thing now for the year 2015. This time we want to use these prices here in this row. So the price of good X was 6. Multiply that again by that quantity that goes into the market basket for good X, which is 6. So we have 6 times 6, and then plus the price of good Y in 2015 was 9, and multiply that by the quantity of Y that goes into our market basket. So we add $9 plus 2. And so we have 36 plus 18, which is 54. So the value of the market basket in 2015 increased to 54. So you can see that the value of the market basket went from 50 to 54. From this is what we're going to want to use to calculate the rate of inflation for going from 2014 to 2015 in this economy, right? So the rate of inflation, we define that as basically the growth rate of the value of the market basket, right? So the growth rate it goes from 50 to 54, right? In 2014 to 2015, it goes from $50 to 54. So the growth rate is the change divided relative to the initial amount. So the change is $54 minus 50. The initial amount is of course 50. And so we end up with $4 over 50, which it's pretty easy to find that is 8%, right? So from these price changes going from $5 to $6 for good X and $10 to $9 for good Y, there happens to be 8% inflation, right? So an interesting thing to note about this problem here is that one of the goods, the price got more expensive, right? The price went up for good X, whereas the price went down for good Y, and they went, so they went in opposite directions, but they went in opposite directions by the same amount, right? $1 in each direction. And so just looking at these price changes, you might not realize that there's actually inflation. And why there actually is 8% inflation is because good X counts for so much more in this problem in terms of the how it weights into the basket of goods. Also, the fact that it's a larger percentage increase in the price, even though they both move by the same amount, right? $1 in opposite directions. This is a 20% increase in the price of good X, whereas it's only a 10% decrease in the price of good Y. So that's another reason for why there's actually inflation. It's because it's a larger percentage for the change, a larger percentage change for the price of good X, and because good X is more prominent in the market basket, and because there's more units of it that go into the market basket. So that's just something that's kind of interesting to note about this problem and where the inflation actually comes from. All right, as always, thank you for watching.